Today we're diving into a fascinating development, the automation of scientific discovery itself.
It's a game changer. We're talking about AI not just assisting scientists, but potentially driving the entire research process.
This isn't just about crunching numbers faster. We're talking about AI generating ideas, testing them, and even writing up the results.
Exactly. It raises some profound questions about the future of science and the role of human researchers.
The article highlights Sakana AI, a Tokyo-based company, as a pioneer in this field. What exactly did they achieve?
Sakana AI developed a tool, AI scientists, that can perform the full cycle of scientific discovery. This includes generating hypotheses, designing experiments, executing those experiments, and then writing a scientific paper about the findings.
This is quite a feat. The article mentions that AI scientists even submitted papers to a machine learning conference. How were those papers received?
One of the papers was accepted by peer reviewers, while the co-founder of Sakana AI, David Ha, admits that the paper wasn't quite at the level of the best human-produced papers. It's still a significant achievement. It demonstrates that an AI can produce work that meets the standards of the scientific community.
So how does AI scientists actually work? What are the key components?
AI Scientist is built on top of existing large language models, or LLMs. It uses these LLMs to search the scientific literature, generate hypotheses, and design research directions. Then it writes code to execute experiments and measures the results. Finally, it uses the LLMs to write a paper describing the findings.
It sounds like a complex system. The article also mentions an automated reviewer. What's the purpose of that?
The automated reviewer is used to evaluate the quality of the AI scientist's output. It helps to ensure that the papers produced by the AI are of a certain standard before they are submitted for peer review.
The article describes AI scientists passing a Turing test for an AI-generated paper. Can you elaborate on that?
In collaboration with the ICLR conference, Sakana AI submitted 3 AI-generated papers to a workshop. Reviewers were informed that some papers might be AI-generated. One of the papers was accepted, suggesting that human reviewers found it indistinguishable from those written by human researchers. This is seen as a Turing test because it shows that the AI can produce work that is convincing enough to pass as human-authored.
This raises some interesting implications. The article touches on the rate of discovery, the reliability of AI-generated research, and the very nature of science itself. Let's start with the rate of discovery. What are the potential benefits and drawbacks of AI accelerating the scientific process?
On the one hand, AI could help us to solve problems much faster. It could explore hundreds of hypotheses simultaneously, leading to breakthroughs that might take human researchers years to achieve. On the other hand, there's a risk of a gray goo of science, a massive influx of papers that are technically sound but intellectually lightweight. This could make it harder to find the truly important and original research.
That's a valid concern. What about the reliability of AI-generated research? The article mentions a circularity trap.
The circularity trap refers to the risk of AI-generated papers being reviewed by AI-generated bots. This could create a closed loop where AI confirms its own biases or hallucinations without human grounding. It's important to remember that indistinguishable from human doesn't always mean true or valuable.
The article also raises the question of what science actually is. How might AI change our understanding of the scientific process?
LLM-based scientists are essentially pattern-matching engines. They may find correlations or code optimizations that work without ever grasping the underlying causal theory. This could lead to a shift from a focus on why to a focus on what works.
So what does this mean for the role of human scientists? Are we on the verge of being replaced by AI?
Not necessarily. The article suggests a new workflow where AI generates a large number of ideas and runs initial code, and then human scientists curate the top ideas and refine them into high-impact papers. In this scenario, AI becomes a co-scientist working alongside humans to accelerate discovery.
The article mentions OpenClaw and Denario as other AI tools being developed for scientific research. How do these tools compare to AI scientists?
OpenClaw, developed by Anthropic, is an open-source AI assistant that's become popular for carrying out scientific tasks. Denario, developed by researchers at the University of Cambridge and the Simons Foundation, is designed to make contributions to multiple fields of research, not just computer science. These tools, along with AI scientists, represent a growing trend towards using AI to augment and automate scientific research.
The article points out that AI scientists is limited to a few fields and is fully dependent on the underlying LLMs it's built on. What are the implications of these limitations?
The fact that AI scientists is limited to a few fields means that it's not a universal solution for all scientific research. And the fact that it's dependent on LLMs means that its capabilities are limited by the capabilities of those LLMs. As LLMs improve, AI scientists will likely become more powerful, but it will always be constrained by the limitations of its underlying technology.
The article highlights the publication of a paper in Nature describing AI scientists. What are the key takeaways from that paper?
The Nature paper provides a comprehensive overview of AI scientists' architecture, outlines new scaling results, and discusses the promise and challenges of AI-generated science. It also details the Turing test experiment at the ICLR conference.
The article mentions that the development of AI scientists involved distinct phases, including proving it's possible. What was the significance of that phase?
In the proving it's possible phase, the researchers demonstrated that AI could autonomously generate novel ideas, create and run experiments to test those ideas, and write a full paper. This was a crucial step because it showed that end-to-end automation of the entire machine learning research process was possible.
The article also mentions a second update where AI scientists was given more freedom to investigate any broadly defined topic in AI research. What was the outcome of that update?
In that update, the researchers submitted unedited, fully AI-generated papers to the rigorous, blind, human peer review process of the ICLR 2025, I can't believe it's not better, ICR-NB workshop. One manuscript achieved an average score of 6.33, surpassing the average human acceptance threshold. This was a significant achievement because it showed that AI could produce work that was not only indistinguishable from human-authored work, but also of high quality.
So what's the overall message here? Is AI poised to revolutionize science, or are we still a long way off?
AI has the potential to revolutionize science, but there are also significant challenges that need to be addressed. We need to develop better ways to evaluate AI-generated research, ensure that it's reliable and unbiased, and redefine the role of human scientists in the age of AI.